Now we are going to discuss about velocity in physics. We have two words here. The one is speed, the other one is velocity. In daily life, speed and velocity seems very similar or same, like displacement and distance. As we discussed, displacement is completely different than the distance, and sometimes they are not equal each other. And here we're going to talk about the distinction between speed and the velocity. So there is a difference between them. They are not same in physics. Maybe in the daily life you can use the one instead of other one, but for the scientific description we cannot use one instead of other one. The velocity we have magnitude and the direction together. So if you are saying the car is moving with the 50 kilometer per hour, if you mention its direction, for example to the east, now you are discussing about the velocity. But only if you mention the velocity of the car, which is 50 kilometer per hour, if you are describing only the magnitude here, so you are talking about the speed. So the important difference between the velocity and the speed is the direction. So for the velocity, we know magnitude and direction. And for the speed, we know only magnitude. And here we have a formula. That formula is the formula of the average speed. And average speed is the distance over time. What was the formula of the average velocity? It was displacement over time taken. Now, for the average speed, we are going to use distance over time, and unit of distance is the meter, unit of time due to SI unit system, second. So, unit of the average speed, it's again meter per second. The unit of distance and displacement, same, but they are completely different than each other. Units of speed and the velocity, they are same, but they are different than each other according to physics. Now we will discuss about velocity can be described by the graphics. So here we have a graphic. The vertical part of the graphic gives us information about the position, and the horizontal side of the graphic gives us information about the time. According to this graphic, we are going to calculate the average velocity or velocity of the car at any point. And we can calculate it due to slope of the line. That slope you have studied in math. So that slope, if you take this angle, what is the slope? It is opposite over adjacent. For example, let's talk about this point. Let's say point A and the point B. If we are talking about the point A, what is the opposite? It is the vertical line over what is the adjacent? It is the horizontal line. And according to this, if we calculate the slope, what is the vertical line? Vertical line is 4 meter. And what is the horizontal line? It is 4 second. So slope gives us information 1 meter per second. So velocity of this car, average velocity of this car, it is 1 meter per second. Simply. And if you remember the formula of the average velocity, V average equal delta x over delta t, and delta x equal x final minus x initial, and the delta t final minus t initial. And if we check the point A again at the graph, what is the initial and final position? Initial position is 0 and the final position is according to point A, 4. So it will be 4 minus 0. And final time is 4 again. And initial time is 0 because it starts from 0. So it will be 4 over 4. So it will be 1 meter per second. So as you see, we have same result here. So slope of the graph give us information about the velocity. Previously we discussed about the velocity and the average velocity. If you are taking long way, we have to discuss about the average velocity. And now the time to discuss about the instantaneous velocity. If you know the meaning of the instantaneous, you know what does the mean of the instantaneous velocity actually. Instantaneous means it is the instant at that moment, we can say. So velocity of object at the some instant or specific point, we can say. We have a graph, speed, we can say this is the velocity, and the time graph. And as you see, this red line give us information about velocity of the car, speed of the car, we can say. And the blue line give us information about the average. But now our point is the instant velocity. So at every second, let's say this is the first second, I'm giving random numbers, second, third second, fourth second, fifth second, like that. So at the first second, let's say velocity is, speed of the car is, let's say 30. At the second, again 30, let's say. At the third second, it's dropped to 0. At the fourth second, it's around, I'm giving the numbers roughly, 25 meter per second. At the fifth second, there is another number. So if we have a specific moment, if we have a specific time, at that specific time, that means we are talking about the instant velocity. That means velocity at the time. I'm gonna explain this with the simulation. Yes, guys, we reached the section review 1.1. So I'm gonna explain some of the questions from here. Question, it says bacterium drift at a constant speed of 3.5 millimeters per second. Petri dish. Petri dish means is this. This is the Petri dish. And the diameter of Petri dish 8.4 centimeters. And this is our x, which is 8.4 centimeter. But in this question, speed given in millimeter per second, so I have to convert centimeter into millimeter. It's gonna be 84 millimeter. And it's asking what is the shortest possible time. So v equal x over t. Due to this, from the cross multiplication, t equal x over v. And the x given 84 millimeter. And v is given 3.5 millimeter per second. So it's gonna be 24 seconds. Thanks for listening. In this question it says a child pushing shopping cart at a speed of 1.5 meter per second. How long will it take? That means here it is asking delta t. How long will it take the child push the cart down an aisle with a length of 9.3 meters? So in the first step, I'm going to write the given speed equal 1.5 meter per second, and another given length, which is the x, is 9.3 meter. And the question says what is the delta t or t. And in the second step, I'm going to write the formula v equal x over t. Then question says what is the t, time equal x over v. In the third step, I will do substitution. T equal x over v. X is 9.3 meter and the v is 1.5 meter per second and the time gonna be 6.2 seconds. Thanks for listening. In this question it says an athlete swims from the north end to south end 50-meter pool in 20 seconds. If we draw north and the south, east and the west. So it is swimming from north to south 50 meters and 20 seconds and makes round trip starting position 22 seconds. So it's return back in 22 seconds. A says what is the average velocity of the first half of the swim? So the average formula is equal delta x over delta t, so that for the first half delta x is the 50 meter and the time given 20 seconds, so it's gonna be 2.5 meter per second. And at the B, it's asking what's the average velocity for the second half. So V average is gonna be delta x over delta t again, and the x is constant because it's coming back on the same way, which is 50 meter, but now time is 22 seconds. So our result gonna be 2.27 meter per second. And at the C, it's saying what's the average velocity for the round trip. That means finally it will return the same position of the initial. So at the C, delta x will be 0 because it's returned the same position. V average is gonna be delta x over delta t. That means 0 over delta t. It must be 0, 2. Thanks for listening. In this question, we have two students walk in the same direction along the straight path. One of it velocity 0.9 meter per second, the other one 1.9 meter per second. So we have two guys and two different velocities. Assuming at the A, it says assuming that they start at same point at the same time, how much sooner does the faster students arrive at the destination 780 meter away? So the guy which is faster, let's say A, it moves from one position to another position, and the guy which is slower, let's say, it moves same position. The total way is the 780 meter, but the faster guy, we can say it is speed 1.9 meter per second. The slower one, let's say V2, 0.9 meter per second. Now I'm going to calculate the both time and I will subtract them each other. For first one, I'm going to say T1, the slow one gonna be T2. And the formula of the V equal x over t. From this, t gonna be equal x over v, and t1 will be x over v1. X is the 780, v1 is the 1.9, and it will be 410.52 second. And the t2 gonna be x over v2, and it will be 780 over 0.9. That result will be 866.66 second. And if we take the difference, we're going to find sooner time. So delta t will be t2 minus t1, and t2 is the 866.66 minus t1 410.52. So it will be equal 456.13 seconds. Now I'm going to solve B. At the B it says how far, asking about X, would the student have to walk so that faster students arrive 5.5 minutes before the slower student. That means 5.5 minutes means 330 seconds sooner it must be, or earlier it must be. And for the first one and the slow one, I will make a chart. And the first one, time t1, I'm going to say, and it will be t. And the v1, 1.9 meter per second. And the slow one, time, I'm gonna say t2. And it's time 330 seconds slower, so it will be t plus 330, and v2 is gonna be 0.9 meter per second again. And they are going to cover same path, so x and x will be their distance, and x equal t1 times v1 here, and here x equal t2 times v2, and x equal t1 is the t times v1 is the 1.9, and the x here equal v2 is the 0.9 times t2 is the t plus 330. So these two x equal each other. That means 1.9 t equal 0.9 t plus, when we multiply these two, we will obtain 297. So when I send this to here, it will be t, and the t gonna be 297 seconds. And this is the time difference, but it's asking far, that means destination difference. So x equals t1 times v1. From this formula I can calculate it. So x equal t1 is the t, so it is 297 times v1 is 1.9, so x gonna be here 564.3 meters. Thanks for listening.